Hello, I'm Andre J, and today I'm going to talk to you about the 1.5 updates for artificial life. So this is a pretty juicy one. We're going to talk about, first I'll go over a little bit about the MIDI latching, which is new. It's new for pretty much nearly everything in the 1.5 updates. And then we're going to talk about the Colorizer, the 3-band Colorizer, which has replaced RGB offset for adding color to artificial life. And then we're going to talk about pulse width modulation and pulse width control, or waveform control, pedestal. We'll go over exactly what that means when we get there. But those are the sort of main things that really help out and increase the fun times with the new version of artificial life. So, without further ado, the first thing I'm going to show you is that, I kind of set up a little fun patch to start with, but I'm going to show you what it looks like and how you can know if your artificial life is updated. There'll be a different splash screen, and it'll kind of show you like what's going on with the Colorizer thing. It'll say 1.5. There you go. We got the actual splash screen this time. And then once it boots up, you'll see a different background image than what usually used to appear on there. And yeah, it'll boot up to the regular old artificial life situation. So you're going to want to have the manual for artificial life open for this, because I'm going to refer to the control schemes on the nano control. That's there where it says, like, 1, 2, 3, 4, 5 for the knobs, 8 through 16 for the sliders, and A, B, C, D, and so on for the buttons, because that will make a difference for following along. But yeah, so MIDI latching is the first thing. What MIDI latching means is, and some of you have been using artificial life for a while, have sort of recognized this may be a really common frustration, is that, so you press buttons to switch back and forth whether your controls control like one set of oscillators or another. And a lot of times, most of the time, it'll just like sliders and knobs will just jump to values when you're like switching modes and stuff. And MIDI latching means that basically all the values will go smoothly. The sort of like the thing to keep in mind is that it may feel at first that the controls are not being responsive to what you're doing, but once you kind of like play around with it a little bit, you'll get the feel for it. So like, for example, if I want to control the amplitude here, I'm going to have to like first move the slider all the way up and then move it down. But if I just keep it in the middle and like tweak it around there, it's not going to suddenly jump to the value. It's only going to jump to the value that it's at, and then it's set at already, and then go back down. Another thing to think about is, so if I want to go in, I press 9R, and that turns on oscillator 0M rotate modulation. I'm going to turn that up a bit. If I then press S9, and that switches the first 3 sets of sliders and knobs to be oscillator 0M controls, everything I do, like, I'll have to latch the MIDI for that to get anything to happen. So I'm going to need to move this kind of the rate knob over a bit before running through 0 before it changes things. If I move like the frequency knob, I have to move the frequency knob back to like default before it'll start changing the frequency. Same thing with amplitude. I'll have to bring amplitude up to 1 in order to like get it to latch on things, and so on and so on. And then if I have all these knobs set to different things, and then I go back to oscillator 0, I will have to latch them again. They won't be set at their default settings. They'll be at wherever they were at last time before I switched over to the oscillator 0. Maybe a little confusing, but check the manual. There's sort of like a really detailed text thing that'll tell you how to sort of get a handle of it yourself. And once you get a handle of it, it'll be really easy. And if you've ever played with like 90s eras, like digital synths with analog interface, like a Korg Prophecy or Korg Z1s or stuff like that, that's sort of a default method for them too, because they would have like, a row of like 4 knobs, and you press different buttons to jump between whatever those 4 knobs actually apply to, and they wouldn't, at least the way I set them up, they wouldn't latch unless they reached their previous value, so that shit would be continuous instead of like stuttering all the time. But yeah, so that's MIDI latching. the next thing I'd like to talk about would be the Colorizer. So previously, if you played around with the S, M, and R for S16, M16, or S15, M15 or R15, and then knob 7 and slider 15, those would be the RGB offset and contrast controls for that. I found that I just wasn't able to get enough of an interesting range of colors with that. So I've replaced it with a 3-band colorizer, and the 3-band colorizer is going to sort of divide up the brightness into 3 ranges, and then you can assign a different hue to each one of those ranges. So the first thing I'll need to do is press R15, and R15 makes both the slider and the knob 7 and 15 control the saturation of everything. So I've bumped up saturation. The default hue for each band is going to be red, so it'll just appear to be red at first. And then I'll press M15, and that'll change it so I can offset or change the hue of the brightest band. So I need to MIDI latch it by going back down to 0, and then I bring it up, and you can see that I can basically cycle through red, yellow, a little bit of orange, green, turquoise, blue, indigo, pinkish, and back up to red. And this is a soft key colorizer, meaning there's going to be like some sort of a little bit of blending that happens in between. So you can see there's like sort of like the strong saturation of the hue right in the middle of the band, and then there's a bit of a gradient that's happening as it overlaps into the red. If I then press S15, that'll control the second brightest band. Make sure to turn it back over to 0 to latch it, and then we can assign a different color there. And then if I have none of the buttons pressed, that's going to control the hue of the darkest band. So we'll just leave it at this. So we've got a green to pinkish purple to blue thing going on. And if you want to kind of see what's going on with like the brightness bands, if we then change the amplitude, so I bring the amplitude down to like under 0.5, and you can see it's only going to show the darkest band, which is green. And as I push it back up, we get back some purple, and then once I get near the top, we get that blue back again. But just if you look right in the middle, you can see what's going on with the soft keying thing, where it's like, it's going to be a little purpley, and then it's going to be like the bright, sort of, the bright almost pastel blue. And then, you know, it's kind of a little muddy of the hue transform between sharp, you know, pink and green, but you can see a little bit of it happening there. But yeah, so that's the colorizer, and we kind of, if we want to do the same thing for oscillator 1, kind of just follow the same things but move the slider instead of the knob. And part of the interesting thing about this different kind of mode too, well, I mean, it's the same thing that the RGB would make, like the way that phase mod and ring mod between the things and the feedback changes too. I'll show you a little bit more when we talk about feedback. There's a little bit of some new feedback modes, which I forgot to mention earlier, and I'm just adding it to my list of things to talk about. All right, but so yeah, the next thing to talk about, well, maybe we'll just play with this a little bit first. Just to kind of like show you what kind of fun things we can do with color. So you can see that color, and I'm doing phase mod feedback in between oscillator 1 and oscillator 2, and the different colors that we have selected are going to make the feedback work in different ways. So that's pretty lovely. If I turn on ring mod, we'll get some clamping on the colors and make things sort of like that strange like digital hue clamp thing happening. But yeah, really nice and goopy, fun times. Getting really super oozy. Some real artificial life forms happening in the signal sphere. This will really start to like show you how much fun it can be once we start adding wave pool into the mix. I won't do that in this video. We're just going to reserve an entire video for how the new artificial life and new wave pool kind of are going to work together in a really interesting and fun way. Oh yeah, something I forgot to mention. So for everybody watching this video right now, you may be interested in like, oh, how do I buy this? How do I make this? So the DIY instructions are all available. Currently not able to sell anything on Etsy right now because I don't have a reliable supply of the Raspberry Pis. The Raspberry Pis are the main controller, the main brains of the operation here. I'm currently thinking about alternative modes of like research, development, and distributing like video synthesis tool sets to people. Most likely what I'll be doing for this year is a sort of like phasing out the whole thing where I build things and sell them to people and try to do a new model where I just focus on research and design and then making like really explicit instructions, video and text based, for people to build their own. This won't really make a huge difference right now for the VSERPI because no one can really get any more Raspberry Pis. I mean, you can get Raspberry Pis, it's just a little hard. They might be more expensive than they would be otherwise. But in order to fund this kind of a thing, I've set up a Patreon page, and the main thing I'll be focusing on will be the desktop version. So if you're just coming to this and you're brand new to it and you're like, oh shit, I want to play with this stuff, I'd invite you to first check out the desktop, the VideoWave suite, the Video Synthesis Ecosphere desktop, and then subscribe to my Patreon. Like, there's a lot of different, monetary things you can subscribe to on a monthly basis. But if I can get enough people to subscribe over there, the first thing I'll focus on will be making the desktop versions really easy to use and easy to install for everyone. Because at the moment they're a little bulky and a little tricky to install. And I do want to make it so like if you just have like a nano control and you plug it in, it'll just kind of be like, it'll default operate the same way as the VSERPI. I think that would be like a great place to start for making the desktop stuff more accessible and making sure people can still get introduced to the world of open source video synthesis design, even though Raspberry Pis are semi-mythological at the moment. But yeah, gotta remember to try to toss that one in each one of these. Anyway, artificial life. So the next fun thing about the artificial life update is pulse width control. And technically speaking, this isn't really width control. From a signal processing standpoint, perhaps a better description would be pedestal, which, I don't think people outside of like hardware designers in the 70s and 80s might understand. Or DC offset, which is also a bit of a misnomer because there's no actual current happening inside of the signals here, but it does function in the theoretical signal world where this is actually happening. This is basically what a DC offset does, where it's just going to kind of boost the signal up and clamp it, or bring the signal down. But let me show you exactly what that means. So in order to access width control, we're going to press S10, that's for oscillator 0, we're back at the default mode. So width control, you can see if I turn it up all the way, and this is a bipolar control, it just clamps everything out at completely white. And as I start to bring it down, you can see that it's increasing the brightness range of everything. So it's just pushing the brightness up, so it doesn't go fully dark. And then if we take it down a bit, you can see that we're losing the brightness range. We've got sort of a little skinnier thing happening here. The main reason I really wanted to throw this pulse width control into here is one, for pulse width modulation between oscillators, and two, because when running this into a wave pool, I really like to have like a really minimal sort of like wiggly line thing happening, so I can do a lot of feedback in the background of it. If you've been following my Instagram last year, you've probably seen like 1.5 million videos that I've done where I was using the desktop versions of Artificial Life. And this was me trying to bring some of the fun stuff, seeing what I could do that seemed really crucial from the desktop versions and bringing it over to the Raspberry Pi versions. And width control seemed like a crucial one. So let me just set the width kind of like at I don't know, a little bit lower than the default. If I then press M10, that's going to let oscillator 1 modulate the width of oscillator 0. So if I turn this up, you can see that oscillator 1, that's what oscillator 1 looks like right now, is basically giving a boost to the amplitude of oscillator 0. If I then start to increase the rate of oscillator 1, I can maybe have it rotate a bit. So we can see that's what the oscillator 1 pulse width modulation works like. If I press S9, and that's going to switch all of the controls back over so it's oscillator 0M, or the first set of controls over, the first 3 sliders and first 3 knobs. And then I press M10. That's going to control the amount of pulse width modulation from oscillator 0M into oscillator 0. So I can either have it do like a negative, and then turn up ring mod, and that'll kind of do some, well actually I won't do anything because I've made it too negative. Yeah, I'll do negative ring mod, and then I'll do positive pulse width modulation. That might be a little too confusing to start with. Yeah, no, let me do just a little bit of negative pulse width modulation, and then let me start modulating the frequency of oscillator 0M and modulating or controlling the rate of oscillator 0M. Alright, does that make sense? As always, you're really going to have to play along with this in order to actually see what I'm doing here, because just listening to me ramble about this might be more confusing than anything else. Another thing we can do is set up the pulse width modulation in a feedback loop. So I'm pressing the oscillator view thing so you can see what's going on with oscillator 1. I'm pressing M13, and that's going to bring up pulse width modulation from oscillator 0 to oscillator 1, and we're going to get a little bit of feedback happening, but a pulse width modulation feedback. You can see that it works a little bit better if we're doing things negative. If I then bring up ring mod a bit, see what that does. Another thing to note is that any combination of ring mod, phase mod, and pulse width modulation between 2 sets of oscillators will result in some kind of a feedback happening, and it'll be different kind of flavors and slightly different textures for each one. But yeah, so with that going on, I can change the press S. What was this? 14. Sorry, M14, S14 to change the overall width of oscillator 1. And let me change the views so we go back to seeing oscillator 0. And that's pretty fun. You can change the overall amplitude of oscillator 0. So it's pretty much mostly just getting amplitude from the pulse width modulation at this point. And now let me add some color. I'm going to press R15. Bring up the saturation. So you can see that changing all of the color to red sort of seems to kill some of the feedback. And then press M15 and then change that hue. You can see with different hues on each bands we'll get different kinds of feedback happening. So maybe we'll leave that one at green, press S, change the other hue to blue. Ooh, this is fun. And maybe purple, a pinkish purple gradient for going down. So you can see that different kinds of color selections will give you different kinds of feedback. So that's pretty nifty. What else? So we also have a different kind of feedback mode happening too. So there's internal feedback happening as well as cross-modulation feedback. Kind of just want to keep exploring this specific mode. Oh yeah, something else which has changed a little bit, and maybe let me start over with a new patch to show you what exactly I'm talking about here, is the phase modulation, the phase modulation between the oscillators. So I'm going to press the reset buttons here. So phase modulation between oscillators is slider 10 and 14. So if I turn up phase modulation, you can see that's what's going on here. And then if I turn up phase modulation, so that was 10, and if I use slider 14, then we get a little bit of feedback happening on that phase modulation. Gives it some nice texture and everything. If I press the R button, that's going to do phase modulation times 10. So you can see without feedback, it goes from that to that. That's pressing R on, R off. If I then add a little bit of feedback in, you can see it's going to get things can get a little bit noisier and grungier. If I turn R14 on, so they're both at like max, then we get some really like almost TV static like noise. And that's pretty fun. Let's see, and also if I turn R10 off, turn phase modulation up all the way, but have R15 on, then we get this kind of a thing happening. So that's sort of the main different thing that's happening with the phase modulation. It's pretty subtle, but it definitely makes a difference. And if you play around with the ring mod on both channels too, you notice that different settings of like the phase mod times 10 on and off do change how the ring mod works too. And we can also do stuff like flip the wraparound fold over switch to get things really noisy going on. But yeah, for those of you who want harsh visual noise or smooth visual noise even, these different kind of settings will help out with that. Or if you just like to see strobing cow patterns. And of course, if things are moving, the different speeds at which they move will change the feedback patterns as well. And as always, the colors that you're using will change the feedback. Changing the colors on oscillator, oscillator 0. Nice and goopy, delightful. Bringing down the amplitude, turning up the pulse width, adding pulse width modulation in. That's smooth. Alright, so the last thing I want to talk about is sort of the new feedback modes. Switch back to default here. So, you probably know already, if I press M16 and then move slider 8, whatever USB input I have will do phase modulation on the oscillators. If I then press A, it'll switch the input, the USB input, into just being a feedback input. So this is sort of an internal feedback where it's just taking the output from the last draw through of oscillator 0 and feeding it back into itself. So it looks kind of like, like MX70 style feedback stuff. But I changed up the ranges and I changed up some of the internal filtering. So like, if I start from 0 and work my way up, you can see, so I'm at about point, like a third of the way over right now. And we get this kind of like liney feedback with a little bit of strobes. And then I get to right about 50% and we get some more chaotic noise things and structures that sort of live on their own. And then once I go over 50%, it gets a lot goopier and cloudier. And the strobing starts to disappear, and it does more kind of like cellular, like a smoother, faded out cellular automata stuff. If I then start to add color in at this point, we turn up the saturation, so you can see that smooths things out a lot. And if I start to change the color of the brightest bits, oh, I just changed all the colors to red. I'm turning down feedback to actually see what colors I'm selecting for each band. Yeah, Yeah, so we'll do a yellow, blue, green kind of a thing. And let me start to crank up the feedback here and see what is different with this color selection. We can see once we get to this point, about 50%, where it starts sort of building its own structures. If I then go to pulse width control for oscillator 1, I can actually crank up the amplitude here and get some different stuff happening as well. So part of what I redesigned the feedback, the internal feedback stuff for, was to work with this kind of pulse, the pedestal thing, and give you a different set of textures to play with. You can see once we crank up the feedback all the way, it's going to be really cloudy instead of stuttering. As I change pulse width to be higher and lower, we get some interesting things happening here. I then sort of pull in pulse width modulation from oscillator 1, and oscillator 1 pulse width modulation as well. We're getting some really interesting sort of landforms happening. And we'll just turn down the feedback in order to see what it looks like. This is what it looks like pretty dry. And then as I start to turn the feedback up a little bit, it'll first start to accentuate the feedback happening here, and then the feedback will start sort of living on its own and kind of like have its own separate artificial life form happening. Yeah. And as I cycle through different colors on the colorizer, we can see it's going to like create different structures and patterns in there. Yeah, that's a pretty good one. A lot of times using like highly complementary colors for different bands is a pretty good idea. I'll talk a little bit more about color design and colorizers in the next video, where I'll be talking about chromatic aberration, the search for Sasquatch, which has been improved from being formerly a 4-band colorizer into now being an 8-band colorizer situation. Oh, excuse me. But yeah, I think that is about all of the basics that you need to know to start having fun with the new version of Artificial Life. If you don't know how to update your image, check out a video I just posted yesterday, one day before this video. It's on the same playlist, the general 1.5 updates playlist, that'll go into detail on how do you update your images. And remember that the VSERPI, this, you know, if things kind of like don't really go well, this might be the last update thing in the last set of videos that we'll be able to do for the VSERPI. If you're interested in helping development continue for all of my open source software and hardware fun times, head on over to my Patreon and do a little subscribe, or head on over to my website and just do like a one-time donation. All of this stuff doesn't just help yourself personally in terms of like being able to have access, continued access tools, but it continues to help everyone else out there who exists in this world of massive wealth disparity and would otherwise not be able to access information and video synthesis tools such as this. And yeah, I guess that's it. I don't know, should I make tote bags for the Patreon? I feel like this is like totally like an NPR BBS pledge drive kind of thing I've been doing here. I'm usually against like merchandising and stuff, but it also might just be funny to make tote bags that people can bring to like, I don't know, where do you go? Like Whole Foods or something. You could be like VSERPI tote bag. Maybe that's a really dumb idea. Let me know in the comments. But yeah, as always, thanks a lot. Have fun, and make sure to check out more of these videos. Alright, bye!